and welcome to another WJEC A level physics question. This time it's question 5 from June 2014's PH4 paper, which is currently in Unit 4. So for 14A we're asked to define gravitational field strength at a point. This is a gravitation question. So gravitational field strength at a point is defined as the force acting on a unit mass at that point. We're also asked to define the gravitational potential at that point. The full definition is that the gravitational potential is the work done in moving a unit mass from infinity to that point. So in a way it's energy per unit mass. Next we're told that Charon is a moon of Pluto and it's got a mass of 1.5 times 10 to the 21 kilograms and its radius is 600 kilometers. And we've got to find the gravitational force exerted by Charon on an object of mass 82 kilograms on the surface. Formula for gravitational force is G m1 m2 over r squared. G is 6.67 times 10 to the minus 11. The two masses are 1.5 times 10 to the 21 and 82, and the R is 600 kilometers. Must remember to turn that into meters squared. Putting those numbers into a calculator gives us an answer of about 22.8 newtons. Next we're going to calculate the gravitational potential energy of the 82 kilogram mass on Charon's surface, and you may ignore Pluto. Formula in the data book is the potential energy is minus G m1 m2 over r. So we've got minus 6.67 times 10 to the minus 11 times 1.5 times 10 to the 21 times 82 all over 600 times 10 to the 3. So a quick save time sort of hint here is you can just edit your previous calculation and remove the squared from the bottom of the calculation. Just saves a little bit of putting figures into the calculator. But don't forget the negative sign. So what we got here is minus 13.7 megajoules. For part C, we've got to calculate the potential energy of the same 82 kilogram mass as if it were on the surface of Pluto. So we can use the same equation, minus 6.67 times 10 to the minus 11 times the mass of Pluto, 1.3 times 10 to the 22 kilograms, times the 82 kilogram mass of the object, over 1150 kilometers. Again, don't forget to turn the kilometers into meters. And also don't forget the negative sign here. So here we get minus 61.8 megajoules. For part D, the 82 kilogram mass is fired from Charon's surface to Pluto, and neglecting energy losses due to resistive forces, we've got to find the change of kinetic energy for this 82 kilogram mass from the instant it was fired to the instant just before it collides with Pluto. So the key here is that the change of kinetic energy of the object is going to be equal to the change of its potential energy, just simply from the law of conservation of energy. So all we need to do is find the difference between those two energies. So we've got a 13.7 and a 61.8. So that's 13.7, yeah. And that will be an answer in megajoules. And when we find that difference, we get about 41.8 megajoules. 48.1 megajoules. Question could have continued by asking us to calculate the speed of the object just before it collides with Pluto, but that's the end of this question. So thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.